All right, today we're diving into one of the toughest engineering challenges out there for any student team, building a Formula SAE electric race car that can actually, finish the race. And this isn't just a random list of tips. Think of this as a strategic blueprint. We're going to use a really structured top-down approach to get you from a blank page all the way to that finish line.
So let's just start with a pretty harsh reality check. A staggering 40% of new EV teams either fail the brutal technical inspection or they just don't finish the endurance race. I mean, think about that. That is a massive number, and it really defines the core challenge we're tackling today. The stakes, they really couldn't be any higher.
And that brings us right to our main strategy, and it's summed up perfectly by this classic racing motto. For a new FSAE electric team, this isn't just a cute saying. It is the entire game plan. A super innovative car that's just sitting in the pits, well, it's completely worthless. Reliability isn't just some nice-to-have feature. It is the only strategy that matters.
So how do we do it? We've broken down the whole development process into 6 key modules. We're using the MECE principle here. That stands for mutually exclusive, collectively exhaustive. Basically, it just means we're going to cover every critical area without any overlap. This is your roadmap, from just an idea to a car that can actually go the distance.
Okay, first up, course strategy and system architecture. The decisions you make right here, at the very beginning, they're going to define the entire DNA of your car. They create ripple effects through the whole project. And trust me, getting this part wrong can lead to some major dead ends and a ton of rework down the line. So let's talk about the key performance targets that really shape your design. You want a total weight under 240 kilos. It's tough, but it's doable. Your peak power is limited by the rules to 80 kilowatts, but your hardware should definitely have some breathing room. And this one's critical. Your battery needs enough juice for the full 22-kilometer endurance race, plus a totally non-negotiable 20% safety margin. Look, if you remember just one thing from this section, please make it this. The 600-volt hard limit is absolutely non-negotiable. Your battery's fully charged, open circuit voltage can never go over this. I've seen teams get tempted. They try to push the limits with a 144 series cell pack, but that puts you dangerously close to a violation and an instant no at tech inspection. Just don't risk it.
Now this brings us to your first huge architectural choice. And for new teams, the path is crystal clear. A 2-wheel drive rear inboard motor setup. It's proven, it's reliable. A 4-wheel drive system with in-wheel motors, that is strategically forbidden. The insane complexity, the added unsprung mass, which is weight your suspension has to fight, and the nightmare of weather sealing, it's just poison for a first-year team.
All right, moving on to Module 2, the high-voltage battery system. This thing is the heart of your car. But it's not just about performance. It's also the single most scrutinized part of your vehicle when you get to tech inspection. They will go over it with a fine-tooth comb.
Getting the foundations right here is everything. We strongly recommend cylindrical cells. Pouch cells, I get it, they're tempting because they're so power dense, but they are a real headache to manage without advanced manufacturing. Stick with what's robust. You also have to segment your pack into smaller, safer modules. And for your battery management system, your BMS, a distributed master-slave setup with ISO-speed communication is the way to go. That ISO-speed protocol is just a super reliable, noise-immune way to make sure all the parts of your BMS are talking to each other safely.
Okay, listen up. This is a fatal checkpoint. Rule EV 5.8 is where so many teams fail. Your temperature sensors they must make direct physical contact with the cell's negative terminal or its bus bar. If an inspector looks in there and sees you're just measuring the air temperature inside the pack, you are done. It's a direct violation, and it will end your competition right there on the spot.
All right, on to our third module, Powertrain and Thermal Management. This section is all about solving the #1 reason cars fail to finish the endurance race: overheating. You can have all the power in the world, but it means absolutely nothing if your car goes into thermal shutdown on lap 5.
A smart choice in components can solve problems before they even start. Take your inverter. If you choose one that's based on silicon carbide or SiC, you can get efficiencies over 98%. That tiny percentage difference might not sound like much, but it means way less waste heat, which drastically cuts down the work your cooling system has to do. It makes the whole car more reliable.
And the best practice for that cooling system? A dual-loop liquid setup. You'll have one low-temperature loop that's just for the battery, keeping it happy and well below that 60 degrees Celsius rule limit. Then, a separate, higher-temperature loop handles the motor and the inverter. Keeping them separate is the key to making sure every component is operating in its perfect thermal window.
Now for Module 4, Electrical Safety and Compliance. The best way to think about this section is as your non-negotiable entry ticket to the racetrack. If you don't get these safety circuits absolutely perfect, you will not be allowed to power on your car. Period.
Across these 3 pillars of safety, there's one phrase you have to burn into your brain: hardware only. Your shutdown circuit, the one connecting all your e-stops, it has to be a pure hardware loop. No software allowed. Your brake system plausibility device, the BSPD, got to use simple, non-programmable logic. And your tractive system active light, it has to be triggered by a hardware circuit that's physically measuring voltage, not by some software message from your controller. It's all about hardware.
Okay, so now that the car is safe, we can finally make it smart. Welcome to Module 5, Control and Electronics. This is where we go from just a basic rolling chassis to an intelligent, competitive race car, using software to unlock the true potential of all that hardware.
Your Vehicle Control Unit, the VCU, that's the brain of the operation. Job number 1 is just compliance. You need a closed-loop power limiter to make sure you never, ever go over that 80 kilowatt rule. After that, it's all about performance. You can implement torque vectoring for incredible cornering, blend regenerative and mechanical braking to get back precious energy, and, this is a big one, you have to make sure your network is secure by isolating that critical powertrain CAN bus.
And now for our final and maybe the most important module of all, validation and testing. This is where you prove that everything you designed on a computer actually works in the harsh reality of the real world. This is where the rubber meets the road, literally.
A structured testing process is not optional. You have to run the gauntlet. You start safely in the lab with hardware in the loop simulation, testing every fault you can possibly imagine. Then you move on to system checks, like a pre-check for the rain test and a leak test for your cooling system. Only then do you head to the track for a full shakedown, which should end with a complete 22-kilometer endurance simulation. And after you finish that endurance run, you get to face the final boss, the heat soak test. You immediately park the car, and for 3 minutes, all that trapped heat in the powertrain just soaks into the whole system. If your temperatures creep up and trigger a fault, you fail. This test is the ultimate proof that your thermal management system actually works.
So let's bring it all together with this decision matrix. It really lays out the 2 clear strategic paths you can take. For a new team, that conservative column on the left, that is your blueprint for success. A 2WD setup, cylindrical cells, solid liquid cooling, a steel space frame, and simple control logic. You've got to avoid the temptations in that aggressive column until you have a car that can consistently finish the race.
And this really is the final, most powerful takeaway. For a new team, reliability is the only key performance indicator that truly matters. A simple, well-built car that completes every single event will always outscore a technically amazing, complex car that fails to finish.
So we'll leave you with this question. You have the blueprint for success now. So take a hard, honest look at your project. Is your team making the disciplined choices that lead to finishing the race? Or are you building a car that's on a path to become another statistic in that 40%? The choice, ultimately, is yours.